It's possible that millions of years ago, where you're sitting now, a gigantic plant-eating dinosaur roamed, leaving its mark all around. One of these ancient giants was the Iguanodon. Its story began with a lucky discovery and developed into a saga full of scientific breakthroughs and cultural significance. Iguanodon, which means iguanatooth, is a type of dinosaur that was first named in 1825. It's known for being a big plant-eating dinosaur that lived about 126 to 122 million years ago during the early Cretaceous period, mainly in areas like Belgium, Germany, England, and Spain. This dinosaur could grow up to about 36 feet long and weigh around 5 tons. One of its standout features is the large thumb spikes, which might have been used for protection against predators, along with long, flexible fingers that helped it grab food. Since it was first described in 1825, Iguanodon has become a big part of popular culture worldwide. Back in 1852, 2 life-sized models of what was then considered Iguanodon, now known as Mantelodon, were built at the Crystal Palace in London, which played a huge role in making the dinosaur famous. These models mistakenly placed the thumb spikes on the nose as horns and depicted the dinosaur as a 4-legged creature similar to an elephant. This was the first time anyone tried to create full-scale dinosaur models. Iguanodon has also made its way into various movies. In Disney's 2000 animated film Dinosaur, an iguanodon named Aladar was the main character, with other iguanodons like Nera, Crone, and Bruton playing key roles. The movie even inspired a ride at Disney's Animal Kingdom, where the goal is to bring an iguanodon back to the present. Iguanodon was also one of the 3 dinosaurs that inspired the creation of Godzilla, alongside Tyrannosaurus Rex and Stegosaurus. It has appeared in several The Land Before Time movies and TV show episodes as well. Besides movies, Iguanodon has been featured in TV documentaries like the BBC's Walking with Dinosaurs, 1999, where it appeared alongside another dinosaur, Dicottodon lakotaensis, which hadn't been officially described at the time. Iguanodon has long been a marker of how public and scientific views on dinosaurs have changed. Its reconstructions have evolved over time. The Victorians were satisfied with the idea of it being a 4-legged, horn-snouted reptile, but in the early 20th century, it was reimagined as a bipedal reptile that used its tail for balance. The discovery of Iguanodon is closely tied to the work of Gideon Mantell and the later involvement of Sir Richard Owen, both of whom played pivotal roles in early paleontology. Gideon Mantell discovered Iguanodon in the early 1820s, initially believing its fossils belonged to a giant crocodile. Though the legend claims his wife found the first teeth, Mantell later admitted he found them himself. In 1824, after initial skepticism from other scientists, the teeth were recognized as belonging to a giant herbivorous reptile, leading Mantell to name it Iguanodon, inspired by the resemblance of its teeth to those of an iguana. Sir Richard Owen, a prominent scientist and creationist, later coined the term dinosauria and promoted a more mammal-like image of dinosaurs, overshadowing Mantell's work. Owen's influence shaped public perception through the famous life-size dinosaur sculptures at the Crystal Palace exhibition, including Iguanodon models that remained the popular image of dinosaurs for decades. In 1878, a significant discovery of Iguanodon fossils was made in a coal mine in Bernissart, Belgium, where 38 skeletons were unearthed. Louis Dolo reconstructed these fossils, challenging earlier depictions of Iguanodon as a bulky, mammal-like creature. He repositioned the spike from its nose to its thumb, reflecting a more accurate anatomy based on evidence. Dolo's reconstructions were among the first complete dinosaur skeletons ever mounted and displayed. However, the fossils suffered from pyrite disease, leading to several rounds of preservation efforts over the years. Dolo's model, depicting Iguanodon in a kangaroo-like pose, dominated public perception until later studies corrected it. showing Iguanodon walked with a horizontal back and a straight tail. In the 21st century, Iguanodon research has led to significant discoveries and taxonomic revisions. Scientists identified remnant proteins in Iguanodon bones, advancing our understanding of dinosaur biology. In 2007, Gregory S. Paul reclassified Iguanodon atherfieldensis as Mantellosaurus, a widely accepted change. David Norman later split I. dawsoni and I. fittoni into beryllium and Hypsilospinus. While many new genera were proposed, most are now considered synonyms of existing genera. The Spanish specimen initially classified as de la Parentia was later recognized as I. bernissartensis, and a new species, I. galvensis, was identified in 2015. Iguanodon were hefty plant eaters that could switch between walking on two legs and all fours. The most well-known species, I. bernissartensis, typically measured around 30 feet long, though some estimates suggest they could reach up to 36 feet. Weight estimates vary, but an I. bernissartensis around 26 feet long might have weighed about 4.2 short tons, with larger ones possibly hitting around 5 tons. These dinosaurs had long, strong arms, with hands designed to support weight, featuring 3 central fingers and spiked thumbs that might have been used for defense or gathering food. Their legs were powerful but not made for speed, and their tails were stiffened by tendons that turned to bone. Iguanodon had large, narrow skulls with beak-like mouths and rows of large iguana-like teeth. Unlike hadrosaurids, Iguanodon had only 1 replacement tooth per position, with up to 29 teeth on each side of the upper jaw and 25 on the lower, indicating they might have had cheeks to help keep food in their mouths while chewing. Iguanodon was recognized early on as a herbivorous dinosaur, but its feeding habits have been debated. Initially, Gideon Mantell compared its toothless jaw to modern and extinct sloths, and speculated it had a prehensile tongue, similar to a giraffe. However, further research showed its tongue was likely muscular and used for moving food around, not gathering it. The structure of Iguanodon's skull allowed its teeth to grind food by rubbing against each other, similar to chewing. Its toothless jaw tips were likely covered in keratin to form a beak for cropping vegetation. The flexible little finger might have helped in manipulating food. Iguanodon, including larger species like I. bernissartensis, could reach food from the ground up to 13 to 16 feet high. It likely ate horsetails, cycads, and conifers, but some suggest its feeding habits may have promoted the growth of early angiosperms by removing gymnosperms. Regardless, Iguanodon was a major herbivore in its ecosystem, sharing its environment with various predators and other herbivores. Early depictions of Iguanodon were based on incomplete fossil remains, leading to a lot of guesswork about its posture. Initially, it was thought to be a quadrupedal creature with horn-like features. However, as more bones were found, it became clear that Iguanodon had much smaller forelimbs compared to its hind limbs, and early reconstructions often showed it in a tripod pose, with its tail dragging on the ground. David Norman later disproved this tripod stance by showing that the tail was too stiffened to support such a posture. Instead, Iguanodon likely held its body horizontally, with features like robust arms and immobile hands, suggesting it could spend time on all fours. As Iguanodon aged, it probably became more quadrupedal, with juvenile specimens having shorter arms compared to adults. When walking as a quadruped, Iguanodon's hands would have faced each other, and it walked in a digitigrade manner on its fingers and toes. It could reach speeds of about 15 miles per hour as a biped, but couldn't gallop on all fours. Tracks from early Cretaceous England, initially hard to interpret, were eventually linked to Iguanodon after the discovery of a 3-toed hind leg in 1857. These tracks, found in various European locations, suggest that Iguanodon might have walked on all fours, though direct evidence is limited. One of Iguanodon's most distinctive features is its thumb spike. Initially thought to be on the nose, It was later correctly identified by Dollo as a modified thumb. This spike was likely used for defense against predators or possibly for breaking seeds and fruits. Although some suggested it might have been connected to a venom gland, this idea is not widely accepted due to the spike's solid structure and lack of grooves for venom. Regarding social behavior, the Bernissart fossils, once thought to indicate mass death from a single event, are now seen as representing multiple mortality events over time. This suggests that Iguanodon might not have been a herding animal, as juvenile fossils are rare at this site. However, other finds, like those at Naden, hint at possible herding behavior due to the more varied age distribution and presence of multiple dinosaur species. There is no evidence that Iguanodon showed sexual dimorphism. Earlier theories suggesting that some specimens represented different sexes have been debunked. A 2017 study revealed considerable individual variation in Iguanodon, particularly in limb and spinal column features. Paleopathological evidence includes a fractured hip bone in one specimen and signs of osteoarthritis in others, indicating that some Iguanodons suffered from joint issues and bone injuries.